Okay, let's talk about adding vectors now. So here are a couple of vectors defined by some points here. So we could have a vector, it could start anywhere going like this. Let's do the first one. And we want to, and we have a purple one here. We want to add these two vectors. Well, the way to do it is really just composition of transformations. You just line these up. You can start the first one anywhere you want. It doesn't matter. Okay. But wherever you end it, that's where you want to start the second vector. So if we want to add, I guess this one's called U and this one's called V. And by the way, watch this. If I can take these guys here, click on that, control, and click on that one, settings, and let's do name and value. Here you have the vectors listed in a row form of vector, right 6 and up 3, right 2 and down 1. And basically you want to think of just sort of walking along this path. This is very much a translation that we're going to be getting to here, which you can maybe see why we're doing these vectors when we're talking about transformations. You start it wherever you want to start. You go across this vector here, which is equivalent to going right 6 and up 3. And then from there, you go along this vector, which is equivalent to going right 2 and down 1. Okay, so it is composition. If you remember composition of functions, the output of one step becomes the input for the next step. So the resulting vector is then the vector that's going to go from here to here. Okay, and so that is our resulting vector, this red one here. Let's go ahead and show its name and value. It's W, but W is also U plus V. Okay, look at the numbers here, 6, 3, and 2, negative 1. Can you use those numbers to get to the 8, 2? Well, hopefully you saw that you just add the 6 and the 2 to get the first one, and add the x components there to get the first x component, add the y components, second components, 3 and negative 1, add together to get 2 here. So ultimately, you know, we went to 6 right on the first one, and we went 2 more right here. Here we went 3 up, but then 1 back down is a total of 2 up. So we ended up going 8 to the right and 2 up. Okay? And so we can see how that works. And we can see a vector addition there. Okay, basically just following the sides of a triangle. So here's another example. 2, negative 3 first, that's the green one first. Then the blue one, negative 7 and 8, left 7 and up 8. The resulting net result is you started at the origin and ended 5 to the left and 5 up from that point. That's the red vector there. You can find it by just taking 2 plus negative 7 to get negative 5, and negative 3 plus 8 to get 5. So it's pretty easy to add vectors if they're in component form. So vector AB plus vector CD is vector A plus C, comma B plus D. Pretty simple. So here, what I'd like you to do for exercise, I think we're up to 4 now. Compute the vector sum 3, 5 plus the vector 4, negative 2. Do it just algebraically first, but then illustrate it like this. Okay? You can start anywhere you want. You don't have to start at the origin. In fact, there's not even numbers on the grid, but let's assume the grid is spaced out one space apart, 1 unit apart on the grid, and illustrate that on the grid by hand. All right, that is vector addition. Okay. You can study other vector operations. For example, in Calculus 2 and 3, perhaps in linear algebra and some other courses, we may study vector operations, including scalar multiplication, dot product, and cross product. And with these operations, they form an algebraic system called a vector space. But for now, we're just going to need vector addition only. and we might come back to more vector exploration maybe in another video. In fact, if you'll look at some of my calculus videos from calculus in my calculus playlist, you'll see uh, some more work on vectors there.